So with histograms, the absolutely key idea you should always need in your head in histograms is that area tells you about the frequency. The height of the bar doesn't tell you about the frequency, the area tells you about the frequency. Now, the interesting thing with these questions is the area doesn't have to be equal to the frequency, the area just is proportional to the frequency, okay? So in effect, it doesn't matter what scale's on here, it doesn't matter what the size of the squares is, you just find the area as the number of squares, or find the area as the number of units, and then you can convert that to the frequency, but you might need to half it, you might need to times it by 3 or some sort of conversion factor to get from area to frequency. But other than that, if you have a GCSE understanding of histograms, it's exactly the same. In the questions, you're looking for one complete row and one complete bar on the table, and then that will tell you enough information to fill in all the missing gaps. If you're looking for, as this question is asking for, how many students took between 36 and 45 minutes to complete the homework, so what frequency is between 36 and 45, you go to the histogram at 36 and at 45, you measure that area, and in this question it turns out that an area of 70.4 means 70.4 students, but it might be that an area on this of 70.4 would mean half that many students or twice that many students. Or you need to make sure that you've got one bar where you look at the frequency from the table and the area on the graph. If you need to convert from area to frequency, work out the conversion factor and work from there. These straight lines here are called a frequency polygon. Just a quick reminder there. Go from the middle of the bars on the histogram, join them up dot to dot with a ruler, and there's your frequency polygon. And that, I think, is all the details. Frequency density is the label that we give to our y-axis for histograms. So the last section for this chapter is comparing data. And if you're comparing two sets of data, really what you should do is look at the information you've got in front of you, make some sensible judgments, give some sensible comments. A lot of this is about common sense. Do involve some numbers in your answers. So at an A-level paper, it's not good enough to look at these box plots and say, well, the average for motorway A is higher than the average for motorway B. You would actually want to put some numbers in there. An exam question from the sample material had a very similar question to this, and it gave 3 marks. So there was 2 marks for making a sensible and accurate observation. So saying things like the interquartile range for motorway A is smaller than the interquartile range for motorway B. The average for motorway A is higher than the average for motorway B, that sort of thing. So there's 2 sensible marks. But the 3rd mark was for accurately reading and quoting some numbers in what you said in those 2 comments. So the question was make 2 comments. It was worth 3 marks. The only way to get 3 marks was to accurately include some numbers in the comments. And really, at this stage, with this difficulty of mathematics and the rest of the paper, you should be expecting to back up your statements with some accurate numbers, even if it doesn't specifically say so. Make sure you're including some numbers in there. Now, it might be, this is an interesting example. To me, the obvious thing here is that motorway A has got higher average. It's quite interesting that the lowest speed on both of the motorways is the same, and the interquartile range for motorway A is bigger than the interquartile, is a smaller range than for motorway B, but on the other hand, the lower quartile for motorway A is the same place as the lower quartile for motorway B. So those are the sort of comments that we want to be making. We want to then make them in context. So the middle 50%, the interquartile range for motorway A, are all travelling as fast as the fastest 25% on motorway B. Okay, so motorway B is a faster road overall. Not everybody travels faster, because the slowest people still travel at 60 miles an hour. But on the whole, you'd be expecting to travel faster on motorway A. More of the data is bunched up here. So that's the point that those are the points that I'd be wanting to make if I was comparing these 2 things. Those are the things that stand out from those diagrams. In order to get the marks, you don't have to make the obvious points. You don't have to make the most important points. Usually, because the way exams work, they need to give you marks if what you say is accurate. But if there's any point in learning this topic at all, it's so that we can see what are the important things about these 2 charts, what are the important things about these 2 bits of data. a good habit to get into, just to get you in the right frame of mind, might be the sort of GCSE advice, which would be to measure the average, the spread for set of data A and set of data B, and then just comment which is higher. So underneath, say, higher for a set of data A and the spread higher for set of data B, or larger for set of data B. And then once you've said, so stage 1, compare those things. Stage 2, tell me which is higher and which is lower. And then stage 3, put it in context. So that's a good sort of structure to have in your mind when answering those kinds of questions.